everyone. So today we're looking at a linear algebra problem involving inner product spaces. So if we're given the inner product of u and w equal to 10, the magnitude of u equal to 8, the magnitude of w equal to 9, where u and w are in a vector space V, and it's an inner product space, sorry, be more specific. I'm going to try to find these two quantities, A and B. So A is the inner product between the vector 1/2 u minus 4w and u, and B is the magnitude of 3u minus 7w. Okay, so in order for us to find these quantities, we need to use a couple properties and some definitions of a real inner product space. All I'm saying with a real inner product space is that the vector space is real, it's over the real numbers. And you're gonna get a real number out of the result here. So we have these properties and definitions. So the first three that you see here are definitions that you have with your, when you're studying a standard inner product. These are part of the definition. There's one more thing to add on for the definition here, but I didn't write it down, but it's not important here, but just I would look that up just to make sure you know all of them just for your own sake. And we have a couple properties here that we're going to use. And finally, we're going to use a definition. And the properties basically have to deal with moving things around and such, put it that way. So for example, if you're taking the inner product of u and v, it's equal to the inner product of v and u. So you're switching it, and then it's like a commutative property of sorts. We have property number 2, the inner product of u plus v and w is equal to the inner product of uw plus vw. So that is like a distributive property. Number 3, the inner product of ku and v, where k is a constant, equals k times the inner product of u and v. And we have a couple properties. The inner product between u and kv equals k times the inner product of uv. And number 5, the inner product of u and v plus w is equal to the inner product of u and v plus the inner product of u and w. And a definition here, when we talk about the magnitude of a vector in a generic inner product space, it's equal to saying the square root of the inner product of u with u. So it's the inner product of a vector with itself. So properties 4 and 5 here are a lot like 2 and 3 here. Just make a note on that. All right, so let's go ahead and get started on part A here to simplify this. Now, the first property that I'm going to use here is part of the definition number 2 here. So the reason I see that is I have two vectors that we're subtracting, but a subtraction is really a sum of a negative inner product with a single element. So I can break this down as 1/2 u, inner product u, plus the inner product of minus 4w with u. Okay. So that is our first property or definition that we use our first step. Then I see that I have a 1/2 in front of my 1/2 u, so I can pull that out of the inner product, goes in front. And then for the second one, I have a -4, and that comes out. Inner product of w and u. And last but not least, before I go ahead and put in values, I'm going to switch wu to uw, okay? And why is that? Because we actually have the inner product of uw being 10. I have to make my quantity that I'm looking at, I'll make it look almost exactly pretty much like what I'm given here with this information that I had originally. And the magnitude of u equals 8, and we're going to make use of that as well, because if by definition, if I said the magnitude of u equals the square root of uu, then if you square that, this becomes the magnitude squared. Okay. And essentially what we're just going to do is, at this point, you just plug in numbers. So it's 1/2 the magnitude of u, which is 8 squared, minus 4 times the magnitude of u and w, which we said was 10. Okay. And whatever that is, that's your result. So this would be 1/2 times 64 minus 40. So 32 minus 40, or -8, is your answer. All right, so then on to part B. So I've got continuing on here with part B. So we're gonna find the magnitude of 3u minus 7w, and that's equal to the square root of 3u minus 7w with inner product 3u minus 7w. Okay, so it's the inner product with itself. And I'm gonna go ahead and use my definition to break this down further. This right here would equal 3u minus 7w, inner product with 3u, plus 3u minus 7w, inner product with minus 7w. And I can further break that down as 3u inner product with 3u plus negative 7w inner product with 3u plus 3u inner product with minus 7w plus minus 7w inner product with minus 7w. Okay. And I'm basically just using the second definition to break this up further. And the next thing I see is I have a bunch of constants in front of my my u's and my v's here, or w's, excuse me, which I can kind of factor out in a sense using the properties. So for that first one, I can take out 2 3's by using, just to go back to see what we're using here, 3 and 4 here. So I can take out 2 3's and you have a u, and then I can take out a minus 7 and a 3, and you get wu, and I can take out a 3 and a negative 7, and a u inner product w, and then finally I would get a plus 7 times 7, 49 w inner product with w, and almost done. I'm gonna take this 9, rewrite it as 9 uu minus 21 wu minus 21 uw, and then plus 49 ww. And let me just change this real quick to u, and I pretty much almost have everything here, except I don't have explicitly written what wu is, but I do know that the same thing as saying uw. So this would be 9 uu minus 21 uw minus 21 uw plus 49 ww, and you would get 9. U and u is the magnitude squared, minus 21 uw minus 21 uw, that's 42 uw, and then plus 49. The magnitude of w and w is, sorry, the inner product of w and w, excuse me, is the magnitude squared. Okay, so that's just from definition number 6, and yeah, you'll just plug in your numbers here. Magnitude of w all squared was 9 squared. This is going to be an 81. So anyways, these are the numbers that you would get. 9 times 8 squared is 64, 42 times 10 is 420, and then I went ahead and just calculated 49 times 9 squared, which is 3969. And if you add that all up, you get a grand total of 4125 here, if I'm correct. So you can simplify this number if you'd want to a little bit more using properties of radicals and such. This definitely, the number will divide by 25, I know that, and that's what I'm trying to get at. You can, break that down as such, but I'm not concentrating on that here right now, so I'll just leave it at B. All right, well, I hope this helps. Thank you for your time.